Okay. Hello and welcome to the next episode of 3D and 30. This is Velo3D's LinkedIn live channel. In the movies, we all watch our movies. We see 3D printers sometimes depicted as these simple devices to just get what you want at the push of a button. But today to produce high value, high quality parts in 2021, there's still more to it. And while Velo3D has taken a significant amount of work out of the process with a full end-to-end solution, making the process as low touch as possible, we've not yet reached that simplicity that we see in science fiction. So as more companies are looking to leverage additive manufacturing and Velo3D in particular for everything from racing cars to missions to Mars, it's now more important than ever to understand exactly what is necessary to print one of these parts successfully. And to help us uncover that story, today we're talking to experts from Stratasys Direct Manufacturing. We have Andrew Carter, Senior Manufacturing Engineer, and Jesse Marin, Manager of Design Services. So welcome to the show. We're also, for the audience that's joining us, we are live today. This is a live session, so feel free to put a question into the comments box or send us a reaction and just let us know how you're doing. So to kind of get us kicked off, Andrew, maybe you could give us a little bit of your background.
Yeah, sure. Hi, Mike, and absolutely. So my career in additive started back in 2012, shortly after I got a Master's of Science degree in Mechanical Engineering from CU Boulder. I was hired by a company called Solid Concepts to execute statistical process control monitoring ongoing SLS, or the polymer powder bed fusion process. At the time, we had 2 metal printers on site, and I quickly gravitated towards the technology. I had the opportunity to be the sole proposer, project manager, and prime investigator of a couple small business innovative research grants. One, we were looking at introducing small cooling features using impingement and film cooling for additively deposited combustion liners. And another one where we were developing the additive manufacturing solution. But what I mean by that is not only the deposition strategy, but also the heat treatment of a novel additive alloy called Manel K500. It's a nickel copper alloy that is very corrosion resistant and great in liquid rocket engines because it's very compatible with liquid oxygen. So shortly after that, Solid Concepts was actually acquired by Stratasys and formed a major entity of what is now called Stratasys Direct Manufacturing. And I had to pivot to a more traditional manufacturing engineering role where I focused on the procedures and controls, not only around the 3D printing systems themselves, but also around the additional post-processing capabilities that we need to leverage to produce additive components to print and specification.
And you mentioned having a couple printers at your first job. Was that your first experience with additive manufacturing?
So no, it wasn't actually. How I got into additive is actually kind of a funny story. So I was entering my my last semester of my graduate work. I was studying fluid dynamics, and I really didn't know what I wanted to do with my career. I went home for winter break, and my father had purchased a MakerBot. And back in those days, it was still a kit that the buyer had to assemble. Arguably, MakerBot really didn't provide very good instructions, and we spent a week assembling it, and we got it working after a week. We executed its first print. I watched it start to finish, and that ended up being the first of many that I've observed.
Nice. And Jesse, I want to kind of bring you into this. Maybe give us a bit of your background, and then what is your first experience with metal?
Sure. Yeah. Hi, Mike. Thank you for asking. Yeah, I started by graduating in mechanical engineering at UCSD. And then out of college, I had a couple of more traditional jobs. I was working for an aerospace manufacturing company. They were doing mainly CNC components. And then I moved into composites manufacturing, working on primary aerostructures for all sorts of different crafts. And then I got a call from a recruiter that said, do you want to work for the quote unquote Google of the engineering world? It's an exciting new industry. And so I ended up interviewing about 10 years ago now. It was in 2011 with Solid Concepts. Andrew previously mentioned them as well. And I started in their project engineering department, which was primarily program management focused on ensuring that the manufacturing that we do aligns with customer requirements. So everything it takes to get a part from the file that you get on your computer to the final part that ships out the door, we have to make sure that we're adhering to various material specifications, dimensional requirements, et cetera, et cetera. And so we have this large project engineering team that we utilize to mitigate risk and ensure that our projects are successful. And then after that, in 2016, we started noticing that there was a gap between what our clients had from a file perspective and the resources that they had for engineering at times to getting that final part out the door. So in 2016, we opened what's called our design services department, to where now we manage the design consultation, and we actually work on education as well with our clients on how to design properly and optimize your parts for the additive manufacturing process. And 5 years later now, here we are today, and happy to be a part of it and leading the department.
Nice. And so the Google of, what do you say, the Google of additive manufacturing, was it, or the Google of manufacturing?
Yeah, the Google of the engineering world is how they phrased it, because it was such a new disruptive technology that really, I mean, there was nothing else like it. And I think even back then, Andrew can talk about how, his experience is probably like mine. I'm sitting there going, I've never seen anything like this. You're learning on the job. You're constantly seeing something new every day. And even to this day, I probably learn something new almost every day about additive. It's just ever growing and so fast paced. So,
and I think everyone knows how Google was able to differentiate itself. How does how does Stratasys Direct differentiate itself? I was the one who did it. I'll take a shot.
So maybe I can take that one. First of all, maybe I'll point to Stratasys as a whole. So Stratasys, of course, produces our FDM PolyJet and some photopolymer systems. And Stratasys is really trying to position itself as the premier polymer solutions provider, not only providing systems, but also parts services. And that's where the Stratasys Direct Manufacturing entity lies. We produce parts out of essentially all commercially available additive technologies. On the metal side of things, we're in a unique situation, right? Stratasys does not offer a metal solution, but we're encouraged by Stratasys to partner with companies like Velo 3D to implement additive metal services to provide this technology to industry. And partnering with companies like Velo, who have really taken a holistic solution to the printing process, it allows Stratasys Direct as a user to focus on the procedures and controls and secondary capabilities to produce components on a serialized production basis to customer specifications and requirements.
And Jesse, I know you've had a role in some of this differentiation in the design side. How do you see Stratasys Direct differentiating itself on that side of things?
Yeah, so it starts with design, right? So obviously the name of my department is the Design Services Department. And so what we like to do is offer our clients an all-encompassing solution. So from the beginning to end, we're checking out your part roadmap. How are you designing your features? Just ensuring that whatever we build is successful and realistic for manufacturing in the additive world. And our differentiation at Stratasys Direct comes from the fact that we have all-encompassing technologies as well. So, we have various different metal machines as well as polymers. And so we have this all-around knowledge that is just this one-stop shop for additive success is what I would call it.
And you mentioned kind of this acquisition that happened earlier on with Solid Concepts, and it sounds like there's more movement and evolution. How is Stratasys Direct evolving today? What is changing in the last couple of years?
Yeah, so we're really positioning additive manufacturing to produce end-use components, whether that be manufacturing aids or components that go propel rockets up to space or drill holes down to search for oil. And we're really seeing a shift from a one-step process of the printing process to encompassing largely conventional techniques to get the part from the additive step to the customer requirements, which allows it to be usable.
And you kind of mentioned components and parts. So let's talk about these parts a little bit. what does this part look like when it comes out of the printer? And I think we might be able to help you out here with an image.
Yeah. So basically, to start off, regardless of the 3D printing process, rarely, if ever, is the part ready for application. And this fact becomes more so apparent with additive manufacturing. So we're looking at a part with representative tensile blanks on a base plate straight off the printer here. This part, of course, needs to, at the bare minimum, be pulled off the base plate, either by a bandsaw or a wire EDM, and then those support structures need to be removed. So we take the stance that the 3D printing portion is arguably producing a near net shaped part that needs to be cleaned up in some fashion. And that can be as simple as mechanical means with removing supports and hand finishing, or as in depth as applying certified heat treatments to precision CNC machining to specialized inspection techniques.
And so you kind of mentioned these heat treatments. I mean, I think I get the machining aspect of it, but what kind of heat treatments are being used and what are they doing?
Yeah, heat treatment is kind of a dirty little secret of additive metal manufacturing. And I mean that because if you're producing dense components off of the additive systems themselves, the heat treatments are the biggest factor in tuning your mechanical and material properties. So at a bare minimum, we like to apply a stress relief cycle while the parts are on the base plate, because the deposition process introduces a lot of stress in the components that if we part the component right off the plate following the process, that part will distort. Stress relief relieves those stresses, and then the distortion doesn't happen. Following that, though, we can homogenize the material with a hot isostatic press. We can then improve ductility with a solution anneal or improve strength following the anneal with a precipitate hardening heat treatment. And all of those are really tuned by the application and the material that is being deposited.
And then I think we have a picture here. Once this part's done, here's kind of what it looks like. And maybe you could talk us through what we're seeing now.
So yeah, this is the same component that we saw on the base plate without any surface left untouched. So this is a shrouded impeller wheel that's roughly 10 inches in diameter. It was in support of a project for Hanwha Power Systems, where this was the part of the energy generator from a solar power plant using critical CO2 as the working fluid. So what we're seeing here is the final machined, heat treated, and inspected shrouded impeller wheel.
Nice. And so there sounds like there's a lot that goes into this. And I know we talked about machining and heat treat, but there's also a little bit of build prep. Maybe you could talk about your thought process on how you prepare something like this for build.
So after the initial steps that maybe I'll let Jesse go into on designing for the additive process, us on the manufacturing floor need to introduce first stock for CNC features, those critical surfaces, and then add those support structures to make it depositable in our additive process. And in those steps, we're looking to really limit the amount of material that we add, because that, of course, increases build time and material consumption. But we're also looking at different build orientations to minimize build time, because it's really the build time that makes up the majority of the cost of the additive deposition process. But as we'll discuss, I think, a little later on, the additive step often times with a component like this is only potentially half or a third of the total value we put into the part, meaning you're only paying a third of the price of the part goes to the additive portion.
All right. So with these supports and the orientation, I mean, before we get into some of those other costs there, now you mentioned cost, but are there impacts to performance that should also be considered?
So yes, in the setup, definitely. So how you orient in the part can tend the part to shift and distort in various ways. So this component is very challenging to produce on really any other additive system, because we would have to pitch it up at 45 degrees. And then there would be support structures on certain sides of the vanes where they wouldn't be on other sides of the vanes. And we'd get a very, I would say warped part or not axisymmetric part. Velo allows us to produce this component in the intended orientation, essentially flat with its axis growing in the vertical direction, which gives us that symmetry that allows us to actually spin this component at the necessary speeds.
So, I mean, Han was kind of in the energy segment of the market. I know we did a webinar recently with you on launcher and the space side of things, and it was a very similar application. Can you talk a little bit about that one and some of the results from that?
Yeah, I would say it's a very similar component, arguably different application, right? This was an energy generation. Launcher is a space company, and Launcher combined several components into a single additive component where we were combining an inducer section to the shrouded impeller section. They were slightly smaller impellers, but we successfully produced those on our Velo system, post-processed them, and then Launcher took those components, spun them in a liquid oxygen-rich environment at 30,000 RPMs, part of their turbo pump machinery to fuel their rocket engines.
Nice. And for our audience today, if you're joining us a little bit late, today we're talking to Stratasys Direct Manufacturing. We're looking at the entire workflow. If you have questions about the additive manufacturing workflow, if there's something that you really want to know, this is a live session. This is a great opportunity for you to get your questions in. Just put them in the comments or give us a reaction, a comment, and hello from the US. I see we have somebody here from India. So welcome to the show. So Jesse, we haven't heard from you in a little bit. I kind of want to swing back to your side. You've got a whole process here and you're on the front end of it. What's it like getting the AM information? I mean, Andrew is right down the hall. Are you able to just kind of call him and kind of get that feedback incorporated? How does that work?
Yeah, so it's also part of the differentiation I feel that Stratasys Direct Manufacturing is we've always been very engineering centric. So, I mean, if you call, you're typically getting some form of an engineer on the phone within the first 5 minutes of your phone call. And so what we do is we like to work with our clients and get them in early in the design process. So the pre-print process is very important to us. So before you even start defining what your critical features are on a particular assembly or a higher level assembly, maybe we'll take a look at the parts around it and see what you can consolidate and, how you need to modify your features, like maybe overhang angles for a particular wall or an aspect ratio. And then the benefit is from that point, I can just work iteratively with Andrew and his team, and we can be throwing these designs back and forth into the build software as well as the design software so that we can properly optimize not only from a successful build perspective, but also from a cost of economy perspective. So seeing, maybe we can fit more parts on a build plate if we orient it in a different direction and maybe make some small changes to some features on the design. And so all of this kind of plays into this additive manufacturing pre-prep to ensure success of the build of the part, and also sets you up for success down the manufacturing line, even all the way up to the dimensional requirements and the critical requirements for the part.
And this is a lot to kind of process and keep in mind. I mean, we sort of talked about a number of different steps. We do have a gift for you if you're joining us today. We have a white paper from Stratasys Direct Manufacturing. The link to that white paper will be in the comments section. So go and take a look at that white paper. It talks about all the secondary processing steps and gives you an enormous amount of detail for that. So if this sounds pretty daunting, we've got a great piece of content for you. So I do want to kind of shift a little bit. We mentioned, you obviously have Velo 3D end-to-end solution on your floor. How does that system change the value add, change your approach to the market for a contract manufacturer?
Yeah, so I think Velo has taken approach to many, to what Stratasys is doing, and it's trying to make the systems easier to use, a lower touch in terms of tuning the systems to deposit the parts and materials that it's designed to function. So as an additive manufacturing contract manufacturer, where traditionally I think our value was in coming up with the strategies and the parameter sets to deposit a wide variety of materials. Velo is really taking that on themselves and really diving into right now select materials to come up with a very robust process. And that allows myself and the team here in Austin to focus on the added steps to deliver our components, right? That includes raw material traceability, part file configuration management, heat treat, CNC, and of course inspection to produce these high value components.
And although additive is additive kind of the bottleneck in this process right now, or what do you see the most challenging areas today?
Yeah, so I think thanks to Velo and arguably other equipment manufacturers, the printing process is becoming more robust, but how to leverage CNC on additively deposited components can be quite challenging. So it's actually the secondaries that become the bottleneck, and it's very painful to end up with a part on its last CNC operation and ending up scrapping it. So not only is it a bottleneck, but it's a costly endeavor as well.
And Jesse, kind of switching over to you there. Do you have any comments? Like what should people think of in terms of the value add that you're going to contribute from the design side, given that you've got access to these types of solutions?
Yeah, so it makes our job from a design side much easier, because in comparison, when you look at competing metals technologies, you have your hammers and you have your sludge hammers. So I would consider Velo 3D to be the sludge hammer. I mean, you might not use it for a simple-ish part, and simple-ish being relative to the additive world. You're going to definitely use it for those more complex parts. So you're not going to use a hammer or a sledgehammer to hammer in a nail. You're going to be using that sledgehammer to hammer in a railroad stake. And that's what it does for me from a design perspective, because it gives us a lot more freedom. Most metals technologies, you're probably looking at 30 to 45 degree overhang angles. Aspect ratios for wall heights versus wall thicknesses are typically pretty limited in comparison to Velo 3D technology, where you can have little to no overhang angle needed, and your aspect ratios are a lot more free to work with. So wall thicknesses are also a little bit more or a little bit less constraining when you're taking a look at the design overall. So it just makes our job easier for pre-prepping for the part design.
Is it kind of like having another tool in the tool bag, or is it like having, I don't know, like a different model of the same tool? I don't know if that's a good analogy, but does that make sense?
Yeah, definitely. I mean, it's definitely the powerhouse, I would say, so you, like I was mentioning it earlier, I was talking about it being the sledgehammer. So, I mean, like, you might not use it for a simple part. You could probably get away with most traditional metals additive technologies. But then you'll get that, for example, inducer impeller that we were referencing that has some pretty complex, heavy overhang angles. And it's either you have to change the design dramatically and make something that might be a compromise in terms of material and performance characteristics for the actual part, or you could use Velo 3D technology and you could just leave it the way it is, and it will perform exactly to your expectations.
And just for anyone who's live, yes, we are accepting questions. So this is a live session, Kyle. So go ahead and send us what you got. Also, hello from, we see Brazil, India. We've got a lot of people from different areas joining us today. So definitely a global outreach on this live session. It's very, very cool to see that. So let me get one while Kyle's prepping his question here. Let me get one kind of focused on the future. Where do you see the future of additive going? Is the market growing? You think it's going to be stable? It's kind of reached its cap? How would you describe that? Maybe we'll go with Andrew.
Yeah, so I truly believe that additive manufacturing as a whole, more so with metals, is purely in its infancy. We're going to see bigger, faster machines that are going to bring down the part price and make it more competitive with traditional means of manufacturing. But I'd also go out on a limb to say that Velo is taking one of the first steps to really make a production grade system. And as we see that trend increase, we may even see specialization in individual industries or for specific applications. So years down the road, I don't think it's too far-fetched to see systems, 3D printing systems designed to deposit, specifically a turbine blade or a rocket booster, for example.
Yeah, and we kind of talk about that in some of our sessions, and I do have to agree. Like the right tool for the job type of an approach, we've seen applications that are, I would argue, somewhat unique to Velo. So that's a very true statement. Jesse, what do you think about the future of AM? Where's this industry going?
It's interesting because we've taken a look at the way that terminology even has changed in the industry. So maybe 5 to 8. Maybe even 10 years ago, there was a common buzz term, and it was called rapid prototyping. And rapid prototyping was kind of what was being thrown around. And now we've just seen that terminology just disappear completely. So now it's just become custom manufacturing, and it's just becoming more and more complex. The applications are opening up. And, it's even allowing for, earlier I was mentioning the freedom of design. So for example, Velo 3D has really freed up the design to be able to implement what's called generative design or topology optimization, which is a common term. And so we also offer that as a design service is optimizing your part for the best strength to weight ratio through complex algorithms that the computer can crunch out. And then you get all these crazy complex ergonomic webby looking designs. And 5 years ago, you probably wouldn't have been able to even touch that design, and now you can build it without an issue. So it's just more complex and more frequent in different industries.
So we do have a couple questions coming in online. There's one here. Is there a low-grade material replacing ductile gray or iron parts to be printed in AM? Any comments on that?
So I'm not familiar with gray iron parts, so I don't know. So my apologies there. Yeah,
I don't know, Jesse, if you have any feedback. I see low-grade material, and I'm wondering if the comment is more like, are there, instead of these titanium, Inconel, very high-end aerospace grade materials, are there more common materials? Maybe
yes.
That's a question.
So maybe it might help, Vivek, if you see maybe a follow-up question might be, what are the applications that you had in mind for this material? What is this traditionally being used in? I would say that we do have a lot of casting grade comparable materials offered. I don't know about irons specifically, but I do know we have a casting grade steel that is offered within the industry of additive. There's also casting grade aluminums that are being offered. So if you throw in another comments about kind of what these parts are being used for, we might be able to give you some better direction.
There's a question on materials, so that's a good segue. With the process behind creating these powders, is it difficult to source? What does the supply look like on the powder side?
Yeah, that's a great question, and where the process starts, right? Powder production has been around for decades, feeding powder into powdered metallurgy process, press and sinter, metal injection molding. So the powders are out there. And powder atomizers have tuned their processes to cater to the additive industry. The challenge they're facing, though, is additive is still such a fraction of a fraction of their customer base. So yes, they're catering to it, but we're still just a fraction of what they provide.
Okay, and we're going to wait and see if. Okay, looks like Jesse. It looks like you got into his question. He says thanks. Vivek says thanks. So for people looking to get into the AM industry or new to AM, what kind of advice would you give them? Maybe Jesse, we'll start with you on this one.
Yeah, I'd say immerse yourself. Say yes. There's that funny movie, Yes Man, but there was a touch of truth to that. Whereas essentially, do your job in the daytime if you're in the industry or getting into it, and then at night, just go check out what the shops are doing, the finishers, and how they're finishing the parts. Go look at how your programmers are setting up and slicing your parts and setting up any parameters. Well, if you're not working with Velo 3D because it's so automated, seeing what they're doing on the programming side of things before to prep your parts, and even earlier in the design process, and just just say yes, and also don't be intimidated by the terminologies, because you're always learning a new acronym every day. To this day, I still can't keep track of all the acronyms, so just constantly say yes and ask questions.
And I do have a question. There is a question. They took your advice. So in the near future, the close future, what is about to come new to the market? Anything new from Stratasys Direct coming out in the market anytime soon?
So on the metal side, we do have a couple materials in development, of course, not offered on the Velo system. We have that dedicated to alloy 718, but we're working with Elementum to look at structural grade aluminums, 7,000 and 6,000 grade aluminums there. And then we have been dabbling a little bit with Invar and Kovar alloys as well, and tuning the process for them.
Nice. And I don't know if that question was for Velo, but we do have some things in the pipe as well. We've got our Sapphire XC, which is our large format printer. That's a 600 millimeter diameter build chamber. So that kind of gets into what we talked about before with the price, the cost going down, the parts getting larger, that type of capability. And then, just like Andrew was mentioning here, we're all working on new metals. So we've got, stainless steel in the pipeline, copper in the pipeline, a number of Inconels today, aluminums today, titaniums today. So I think everyone's kind of looking at the same thing. We want to get the cost down. We want to increase the variety of metals continually. But Andrew, kind of coming back to you on that advice question, what advice would you give to somebody who's new to the AM industry?
I think just recognize it's evolving at just a crazy rate. What we learned today, hopefully we can build on to tomorrow and keep growing the additive industry. But don't get intimidated by the knowledge out there and the rate that we're developing. It's exciting to be a part of it. Very cool.
One last question. Bob's asking, what is the highest precision that you can achieve with simple or more complex parts?
Yeah, so I would look at what we're doing to the part right off the systems. We're looking at plus or minus 4 to 5 thou, but we introduced those secondary processes to improve that. Right, we're CNC machining them down to plus or minus half a thou.
Yeah, if you have critical requirements regarding sealing surfaces or volume control on a part, I mean, these are all things that we can address in secondary post-processing. So it's really how tight do you want to get it, and can we achieve it in the secondary post-processes?
There's a question here. I'm going to sort of interpret it a little bit, but what is a good application to bring for metal 3D printing?
So it goes to, I think, low volume, complex components where you do have a little bit of design freedom. It strengthens the case when it's hard to produce conventionally. Is it really hard to cast and machine? Those are great cases to bring to Jesse and the team.
Secondary application would be, is this design constantly changing? So more oftentimes than not, you might have an inducer, an impeller that you're still doing a bunch of testing on. And so you want to get that same, whether it's the final production process or whether additive is the final, you want to get those same performance properties and then be able to tweak your design along the way. And this is perfect for that because you're always essentially building on your virtual inventory. It's just one-offs until you get your final design locked in.
I just noticed we did run over a little bit on time with the questions. So thank you for working with us, and thank you, audience, for submitting those questions. Great questions. I do want to give Andrew and Jesse a chance to, what are your closing thoughts? And finally, how do people get in touch with you? What's the best way to contact you? And maybe Andrew, you can kick it off.
So yeah, my contact information, we'll put it in the comments below the LinkedIn Live video. But just in closing, it's a good thing to walk away that additive manufacturing today is just it's a complex process where the 3D printing part is just an incremental step in the overall process.
And Jesse?
Closing thoughts are well, actually, I'll start off with my contact information. It will also be in the comments, but it will be SDM Design Services at stratasysdirect.com. And don't hesitate to shoot us an email. We're here not only for contract manufacturing, but knowledge building. We want to partner with you and ensure that we're helping you set yourself up for success in that. And I just saw Daniel is saying hello from Brazil. So boa tarde, tudo bem? Sou brasileiro também. Aprecio você estar aqui nesse webinar.
Okay, can't top that. All right, so this is 3D30. This is Velo3D's LinkedIn Live channel. We do these sessions about once every 2 weeks. So if you're interested in learning more about additive manufacturing or about Velo3D in general, please follow us and stay up to date on the latest sessions. Also, please give a follow to Stratasys Direct Manufacturing. If you're looking to manufacture some parts, high-performance parts, they're a great resource for you. We do have a gift for you today. If you look in the comments, probably about 5 minutes, give us a little bit of time to post that in there. We have that white paper on secondary processing from Stratasys. So this is a great resource to learn even more about the industry. So pay attention for that, and obviously the contact information to get in touch with both Jesse and Andrew. So thank you all for joining us today, and stay tuned. 2 weeks, we'll be kicking off another session.
Thanks for having us, Mike.